Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. This is your science teacher, Mrs. Madiha Ashraf. Welcome to all of you in General Science class. Today we are going to start a new chapter, chapter number 7, that is electricity and energy. The objectives of this lesson are, at the end of this lesson, you will be able to describe some useful energy transfer devices, energy conversion from one form to other. You will know about the law of conservation of energy, and you will be able to draw the Sankey diagram to show energy changes. Let's recall what is energy. Energy is the ability to do work. For example, the moving ball, moving wind, all they have energy. Electrical energy, gasoline, solar energy are the various forms of energy. What happened if we hit a ball? We use energy. This energy is converted to other form of energy. As a result, it starts moving. And after some time, the ball comes to the rest. What does it mean? Is the energy is destroyed? No, this energy is not destroyed, but it has lost the energy into an other form. Let's see the different types of energy. What two basic type of energies are? These are kinetic energy and potential energy. Kinetic energy, it is the energy that is due to the motion of an object. And potential energy is the stored energy in an object. While the other forms are mechanical energy, this is also due to the movement. Radiation, as the name shows, radiant energy. Electrical energy, chemical energy, nuclear energy and thermal energy. These all are whether these are due to the motion of an object or stored in the object. Our today's topic is energy conversion or energy transformation. In our previous class, we have discussed the hydroelectric power. What is a hydroelectric power? In which the energy of the flowing or falling water is used to convert it into the electrical energy. The flowing water has the mechanical energy or kinetic energy. This energy can be transformed into electrical energy. So this is how the one form of energy can be converted into other forms. This is named as energy transformation or energy conversion. Energy transformation and conservation. Most form of energy can be transformed into other forms. There are some examples. Look, the first example. Can you guess which type of the energy transformation take place? Yes, this is the wind form. Wind energy is used to move the windmill. That is mechanical energy. This mechanical energy now converts to electrical energy. In the second case, solar energy is used by the plants for making food. Which energy is stored in the food? That is the chemical energy. So solar energy or the thermal energy, the heat energy is converted into the chemical energy. When plants are eaten by the consumers, then this energy, the food which we obtain from the plants, contain chemical energy. This chemical energy is converted into the other form of energy. Some of the energy is used for their body growth by cell tissues and other process like respiration, and some amount of energy is also lost in the form of heat. When the fuels are burned, the chemical energy is converted into the thermal energy and other form of energy. Can you guess what type of energy take place or what observe in this diagram? Well, the electrical energy in the computer converts into light energy, sound energy, and heat energy. So what is energy transformation? We can define energy conversion or energy transformation. A change from one form of energy to another is called energy transformation. Energy transformation can involve the single transformation or the multiple transformation. What does it mean, single transformation? It means that one form of energy converts into an other form, while if it gives more than two forms of energy, then it will be named as the multiple transformation. Like in the case of computer, electrical energy converts into light energy, into heat energy, into sound energy. So this is the multiple transformation. While if here in this example, the mechanical energy is converted into the electrical energy, then this is named as the single transformation. Now see some examples, but before we will see what is conservation. Energy conservation. If you set a spinner, will it remain in motion forever? No, it will not. Then what happened to its energy? Is the energy destroyed? Again, the answer is no. It means the energy is not destroyed, but it changed into an other form. This is named as conservation. Conservation means remain same or constant. So the law of conservation of energy states when one form of energy is transformed to another, no energy is destroyed in this process. Energy is neither created nor destroyed, but it changed from one form to another form. This is named as law of conservation of energy. Total amount of energy before and after remains same. How? If you add up all the new form of energy after transformation, it become equal, or these are equal to the original energy which we have taken in the start. So that's what is named as the conservation of energy or the law of conservation. Now we'll see single transformation example. Sometimes one form of energy is needed to be transformed into another to get work done. For example, in a toaster transformed electrical energy into thermal energy or into heat energy. This heat energy toast up the bread. So what energy transformation take place? Electrical energy converts into the thermal energy only. So this is single transformation. A cell phone transform electrical energy into electromagnetic energy that travels to the other phones. So electrical energy converts into electrical energy. Electromagnetic energy is the single transformation examples. Can you guess some other examples from your daily life that converts the only single transformation? Multiple transformation. Often a series of energy transformation is needed to do work. Where? In our daily life, we have seen the example of burning a matchstick. When we strike a matchstick or rub the matchstick, what we do? We are providing now the mechanical energy. We are moving it on. So this is mechanical energy. This mechanical energy produce the heat energy. Like we rub the hands, it produce heat. So mechanical energy produce the heat energy here in this case. This heat energy or the thermal energy causes the particle in the match to release chemical energy. What does it mean? The chemical which is attached with the match. This heat energy causes this chemical to release the chemical energy. This chemical energy transform or it start burning to produce the heat energy. We only do not get the heat, but we also see the light here. So mechanical energy not only produce the heat or thermal energy, but it also give us the light energy. So this is how the series of energy transformation take place in this example. That's why it is named as multiple transformation. How many energies are formed here? Can you name these energy? Yes. we have formed thermal energy and light energy. We have taken the start from mechanical energy. Let's see another example of multiple transformation. In a car engine, another series of energy conversions occur. How? The fuel have to burn. It needs spark. This spark comes from the electrical energy. So electrical energy produces the spark. This spark is actually the heat energy. This heat energy release chemical energy from the fuel. Fuel start burning now. The fuel has stored the chemical energy. This chemical energy is now converted into thermal energy. This thermal energy now moves the car and produce mechanical energy. How many type of the energy conversions take place? Electrical energy converts to spark or thermal energy. This thermal energy converts or release chemical energy, and at last it produces the mechanical energy. Which energy is stored in the fuel? That is named as chemical energy. This chemical energy converts to heat energy and mechanical energy. The energy transformation, especially the electrical energy transformations, are shown here. When you enter a room and press a button, you see your room light up. The electrical energy converts into light, and some energy is also lost in the form of heat as the bulb becomes warm. Some electrical appliances are shown here which convert electrical energy to other form of energy. Like in the first example, electrical energy is converted into the heat energy. In a lamp, electrical energy is converted into light because the main purpose of lamp is to produce light, while some of energy is wasted in the form of heat energy. In a computer or in a TV, electrical energy is converted more than one forms. It produces light, it produces sound energy, and it also produces heat. So various forms of energy are produced. In a blender, electrical energy converts into movement. It produces sound energy, and also produce the heat energy. So can you name now where the multiple transformation, where more than one form of energies are formed? Yes, second, third and fourth case. While the first one is the case where only one input and one output, electrical energy just convert into the heat energy. So it is the single transformation. Now we will see the Sankey diagram. What is the Sankey diagram? We have discussed the energy conversion or energy transformation. This energy transformation can be simply represented by drawing a diagram. That is named as Sankey diagram on the name of a scientist. Sankey diagram are a type of flow diagram in which the width of the arrow is proportional to the amount of energy. How we can define a Sankey diagram? It is a simple way of showing energy conversion, and the width of the band are representing the energy production, which energy is formed, where it is utilized, and how much energy is lost. Now how to draw? Like we have an example, energy saving bulb convert 80% electrical energy into light, while the other amount of energy is lost. Draw the Sankey diagram for this. The main input is the electrical energy. This energy is converted into light energy. So what we will do, we will draw an arrow representing the output energy, that is the light energy, towards the right side. Why, if there is any loss, then we will draw or split the main arrow into the smaller arrow according to how much there is loss towards the downward direction, which represents the loss or other form of heat. Like in this case, the width of this arrow is more or it is thicker, so it means more light is produced, and narrow the width mean lesser heat is lost. So you can first of all find it out, like in the previous case we have done energy transformation, that which appliances will produce which energy and how much other form of energy or heat is produced there. So we can draw the Sankey diagram. There is an activity that is similar to this example that will help you to understand how to draw the Sankey diagram. Let's look at the example of filament light bulb, which we have to draw the Sankey diagram. A filament light bulb only uses about 10% of the input energy to generate light. The rest is wasted. See this example carefully. A filament light bulb only convert 10% of input energy into light energy, while the rest of energy is wasted because it warm up in the surrounding air, or energy is lost in the form of heat. So Sankey diagram must split into two parts, one for light and one for the thermal energy or the heat energy. The thermal energy arrow must be 90% of width. It means it will be thicker one. And the light arrow, that is about 10% in width, or it is our output. How we can draw electrical energy, that is 100%. First of all, we will draw an arrow towards right side which are showing 10% light energy is produced, while a downward arrow that is having more width is 90% and it is showing the thermal energy. So this is how we can draw the Sankey diagram with different input and different output. Now this is the time for test yourself. Question number 1. What is Sankey diagram? What is the definition of Sankey diagram? It is a simple way of showing the energy transfer. It tells us about, number 1, about how much energy is transferred or the amount of energy is transferred. The width of the arrow tells us about the amount of energy transferred, where it is used light, and is there any loss of heat of energy or not. And you have to give example and draw the Sankey diagram along with this question. Then question number 2. A light bulb is 80% efficient. What does it mean? 80% efficient mean that light bulb convert 80% of electrical energy into light energy, and rest of energy is lost in the form of heat. There's an assignment or activity for you. You have to observe the given pictures and you have to identify what type of the energy conversions take place or occur in these all, and write down your answer and to submit. First picture is showing the lights. You have to write down that which energy changes are occurring here. In the second case, what type of energy do you observe? Name the electrical appliance device, then it convert electrical energy into heat energy or whatever you have observed. Some more examples are here. Electric motor. Electric motor consume electrical energy and convert this electrical energy. It start moving into mechanical energy. If it produce sound, you can also write that. And if you think that it lost the heat, you can also write the heat over there. Use the iron. For what purpose? You can write electrical energy is converted into dash, dash and dash. What these are? These are, do think about it and do answer by yourself. This is about buzzer. The diagram is representing that what is happening here, and there is a bell also, which also showing two things now about these appliances. And write down your observation that the following transformation or energy transformation occur in all these, and share your answer. This is all about our today's lesson. Thank you, students. Have a nice day. Allah Hafiz.